All right, so in this video, I'll be talking through pages 26, 27, and 28 in the notes packet. This is where we're doing more IB style inverse functions. So we're working with inverse functions, kind of applying them in more complicated situations. So if we look at the first one, see that a radius width of a cylindrical container with height x centimeters is r of x is equal to 56 over x, where x ranges from 4 to 16. So this is our domain of R over here. For the range of R, we want to figure out what are the range of values that R is going to take on. Well, the biggest value of R is going to happen when we divide 56 by the smallest possible value of x. So that means the smallest value of R is going to be 56 over 4, right? 56, or sorry, that will be the biggest value of R. Yeah, so the smallest value of R is going to happen when we divide it by the biggest x, right? So we divide it by a bigger x, we're getting a smaller number. So our smallest value of R is going to be 56 divided by the biggest x in our domain, 16. Going to be less than or equal to x is going to be less than or equal to, and then 56 over 4 is going to be the biggest value, and sorry, here we're doing range, so we should be looking at y, or r of x, 56 over 4. If we simplify this down a little bit, we can turn 56 over 16 to 19 over 4. We can turn 56 over 4 to just 19. And so there's the range. All right. So now we have this function, r-1 is the inverse function of r. And what that means is, and we're trying to find r-1 of 8. The other way of thinking about that is, well, if we input 8, if we're looking for the output value when we input 8 into our inverse function, that's the same as saying, where does our regular function r of x equal 8? Because if r of x equals 8, then whatever that x value is going to be the output when we input 8 into the original function. So that means 8 is going to be equal to 56 over x. Multiply both sides by x, and you get 8x equals 56. And you get that x equals 7. So r-1 of 8 is 7. And then interpret the answer. So remember, this is saying that the radius of a cylindrical container with height x is 56 over x. So this is saying a cylindrical, how do you spell cylindrical? Cylindrical container with a radius of 7 centimeters. Sorry, with a height of 7 centimeters. Has a radius of 8 centimeters. Because our original function inputs the height and outputs the radius. So our inverse function must input the radius of 8 and output the height of 7. All right, so the range of r-1, this is actually pretty straightforward because we know the range of the inverse function is the domain of our regular function. This is going to be 4 is less than or equal to x is less than or equal to 16. All right, now we have this function here. So you want to find the domain and range of this function, and you can go ahead and graph it and get a sense of what it's going to look like, and you'll see that the domain is going to be x is greater than or equal to -5, and the range is going to be y is greater than or equal to 0. And then for b, we want to try and find the value of the inverse operation of 6. So the other way of thinking about this, right, if we're looking for f -1 of the square root of 6, that means we're looking for what value of x, right, what input in our original function is going to make f of x equal the square root of 6. And our original function is x plus 5 is equal to the square root of 6. So when we input 1, we output the square root of 6, and that means if we input the square root of 6 into our inverse function, well, we're going to output 1. Okay, this one has a more concrete application here. So the subscription fee for an online project management software by AB Tech is $40 per month. If the customer buys for a whole year in advance, a discount of $130 is applied. So then they give this model to represent this, and n is greater than or equal to 12 because you have to buy at least a month in order to earn the discount. So the total cost of buying a subscription for 2 years, that's going to be P of 24 because there are 24 months in 2 years, which is going to be 40 times 24 minus 130. Let's see if I have my calculator handy. So go over to the calculator. 40 times 24. 40 times 24 minus 130 is $830. If we're looking for the inverse function evaluated at 1790, remember that's like saying for what input value, so what value n is the output 1790. So we want to solve that by going 40n minus 130, right, our original function, equal to 1790, meaning that 40n should be equal to 1920. If we do 1920 divided by 40, it'd be 48. So P -1 of 1790 equals 48. In other words, you need to buy a subscription for 48 months, and then the cost will be $1,790. The subscription price for a different online management tool is $35 per month. However, customers can only purchase annually in advance, and there's no discount. So total subscription cost of the first software is less than, or if the second of this software is less than this software, as long as n is greater than k. All right, so let's start by modeling each of them. So we already know that AB Tech, that function, P of n, the price per a month of software, is going to be 40n minus 130. And then YZ Tech, that's just modeled by 35n. And so our question is, for what value of n, what's the minimum value of n for which this is going to be cheaper than this? So in other words, for what values of n is 35n less than 40n minus 130? And if we solve that inequality out, we're going to get -5n is less than -130, which means n is going to be greater than 26 if we divide both sides there by -5. So the smallest value of k there is going to be 26. It'll take 26 months in order for this brand to be cheaper than this brand. Okay. And these questions down here can get a little bit tricky. So we have a function defined by 3 minus this for these values, -9 to 9, where x cannot be 3. So we want to find the range of this function. Again, to find the range, we want to look for... I think the easiest way to find the range, actually, is just to go ahead and graph it here. So if we go 3 minus 12 divided by x plus 3, and we hit graph. And we only want to look on the window -9 to 9, because those are where x values are restricted. So the range here is going to be everywhere besides that little strip in the middle. So if you imagine the y values here, start at the bottom of the screen, you're defined all the way up along that bottom line, but then there's a gap before the bigger line starts. And what is the upper range of that gap? Well, it is f of 9. That's where it starts on the y. And f of -9 is where it ends. So for the range there, we want to find g of 9, which is 3 minus 12 over 9 plus 3, which is going to be 3 minus 12 over 12, 3 minus 1, or 2. And then g of -9 is equal to 3 minus 12 over -9 plus 3, which is 3 minus 12 over 6, or 3 minus 2, which is 1. So that means the range of g here, we could say is y is greater than or equal to 2, or y is less than or equal to 1. But not in between them, right? If we look at the graph, between y equals 1 and y equals 2, and if I look at what is my window here, okay. All right, so I had f of, right, I forgot a negative sign there. So we want to be very careful here. And that this is going to be 3 minus 12 over -6, which is the same as 3 minus -2, which is the same as 5. So the range is actually y is greater than or equal to 5, or y is less than or equal to 2. Right? If we go back to the graph, there we go. We can see that above 5 we're defined, below 2 we're defined, but not in that gap in the middle. Okay, so now to find g -1 of 0, that's like saying what do we need to input into our original function to output 0? So we're looking for the 0 of the function here. And we can do that in our graphing calculator. if we just set y2 to be equal to 0, then we graph. Second calc trace, intersect. First function, second function, guess. And you can see that when we input 1 into our original function, we output 0, meaning if we input 0 into our inverse function, we need to output 1. All right, and one final page here. So the circumference of a given circle can be represented by the function, the circumference as a function of area is 2 pi times the square root of area over pi, where area is positive, and A is the area of the circle. Okay, so we have any positive area, you plug it into this function, and you're going to output the circumference of the circle. And we have this graph that shows all of the values from circles of no area up to circles of 24. And then what is the circumference of each of those circles? So C of 24 means the circumference of an area, the circumference of a circle with area 24. And so that's going to be C of 24 is equal to 2 pi times the square root of 24 over pi. And we're going to want to plug this into our calculator. So we got, I'm going to start by doing the square root of 24 over pi. And you can do pi by doing the second low caret button there. And that gets us to be about 2.7. I'm going to multiply that back by 2 pi. So we get 17.4 as our value. And we want to draw the inverse function here. So remember, the inverse function occurs when we invert it, right, reflect it over the line y equals x. So our inverse function is going to look something like this. And then in the context of the question, explain the meaning of c negative 1 of 2 pi equals pi. So in our original function, we're inputting an area and we're outputting a circumference. So it means in our inverse function, we must input a circumference and output an area. So that means that a circle with circumference of 2 pi has an area of pi. Yep. And if you think about that, that makes sense because the circumference is 2 pi, or is pi times the diameter, right? Or 2 pi times the radius. So if the circumference is 2 pi, then that means the radius is 1. And if the radius is 1, then the area, which is pi times the radius squared, pi times 1 squared, which is pi. Okay? And then down here, one last question. Function is defined by f of x is equal to the square root of x plus 1, x squared minus 4 over x squared minus 4 on this domain. And so we want to start by finding the range of f. And this is one where I think graphing it to get an idea of what it's going to do would be helpful for us. Let's do the square root. Let's do parentheses around that. Square root of x plus 4 divided by x squared plus 4, x squared minus 4, sorry. And then for our window, let's change our x to be the x that we care about, -1 to 5, right? That way we get a sense of what part of the function is actually being included there. All right, so for the range there, it looks like we're going to have everything except for 0. Or at least near 2. Right, we actually want to plug in, we want to figure out what are the values at those border points. So when x is 5, y is 0.142. So the range of f is y is then greater than 0.1428 or 143. And then second trace value, -1, -0.577. All right. So that's our range, right? Y has to be greater than that or less than that. We want to figure out what is f -1 of 2/5. I think the easiest way to do this is to think about for what value of our regular function f of x is equal to 2/5. In other words, square root of x plus 1 over x squared minus 4 is equal to 2/5. And now here, you might not know where to go from here, right? This is kind of not this is not a straightforward situation here. Algebraically, if you start kind of moving this over there, squaring things, it's going to get very messy very quickly. So I would encourage you to take a step back and let's think about, let's essentially look at two different equations here, right? What if we try and set the numerator equal to 2? And then the denominator equal to 5. Because if we can get those two things to be true, then we've solved the equation. So we look at the top one. This is going to become x plus 1 equals 4 when we square both sides, or x equals 3. And if we plug 3 into the second equation, we're going to get 9. Sorry, that should be a -4. I copied the function wrong down, or down wrong. That should be a minus. That should be a minus, so 9 minus 4 would again be 5. So here, if we plug x equals 3 in, then both the numerator and the denominator end up being 2 and 5. So when we input 3 into our original function, we're going to get 2/5, meaning if we input 2/5 into our inverse function, well, we have to output 3.